All right, let's get started with number 10 from section 3.3. We have a position function. X of t is equal to the inverse sine of root t over 4. I'm going to make a note. This is position. We're asked to find the velocity at the given time. And in this case, the given time is t equals 4. So we are after v of 4. Let's get going. And first, let's find v of t. So the velocity with respect to t is the first derivative of position. So we're looking at the derivative of an inverse sine of the square root of t over 4. So we're going to start with the inverse sine derivative and then get into the chain rule. So we have a 1 over the square root of 1 minus what's inside that inverse sine squared. So we have root t over 4 quantity squared. Then by the chain rule, we need to multiply by the derivative of root t over 4. And you may think of this as 1/4 t to the 1/2. So we're multiplying by a 1/8 t to the negative 1/2. So now let's simplify that. Wait on the bell here to get finished. Let's simplify that just a little bit. And we can bring the 8 to the denominator. We can bring the root t to the denominator. We can also do some work on the root t over 4 quantity squared. So this is going to be 1 over the square root of 1 minus, and this is now going to become a t over 16, because root t squared is t and 4 squared is 16. And then times a 1 over an 8 square root of t. So we can stop here with the simplification and look at finding v of 4. But I want to do this a couple different ways just to get an idea of another way to simplify this derivative. We can start here, like I said, with 1 over a square root of 1 minus a 4 over 16 times a 1 over 8 root 4. And this will simplify down for us into a 1 over, now that's a root 1 minus 4/16. So since 4/16 is 1/4, 1 minus 1/4 is 3/4. So we have a square root of a 3/4 here, and then times a 1 over an 8 times, since the root 4 is a 2, I'm going to call this 1 over 16. And then I can look at the root 3 over 4 as a root 3 over a root 4. So that's now a 1 over root 3 over 2 times a 16, which gives us then a 1 over 8 root 3, which can be a final answer, or if we rationalize, that's root 3 over 24. And either of those would be acceptable in a free response question. But we can simplify this derivative back up to the velocity function a little bit differently. If we look at the denominator of the first fraction, the root 1 minus t over 16, and put the 1 minus t over 16 together. So we're thinking of the 1 as a 16 over a 16. I'll make a note of that here. And then this becomes a 1 over the square root of a 16 minus t over a 16, which then can become I'm going to draw a little arrow over here, a 1 over a root 16 minus t, and then that's over a 4, since root 16 is a 4. And then multiply this by that 1 over 8 root t. Well, the 4 and the 8 make a 2, and now we're looking at a simplified derivative, something like this, a 2 root t, and then times a root 16 minus t. So if we plugged in a 4 to this, and we had a 1 over 2 times a root 4 times a root 16 minus 4, what do we end up with? Well, this is a 2 times 2, which is 4. So that's a 1 over 4. And then this is a root 8. Well, root 8 we know simplifies to a 2 root, it simplifies to a 2 root 2. So this is 1 over 4 times 2 root 2. And that's a 1 over, oh, that's not 8, that's 12. Let's try that again. Thought that sounded weird. So then that's a 1 over 4 times, this is a 2 root 3, so that's 1 over 8 root 3, and we're back to where we were over here. So it's really a preference of which way you want to simplify, either before or after you plug that 4 into the velocity function. I would personally do it this first way. So that's number 10 from 3.3.